So the title of my project is Non-Destructive Evaluation of Composite to Steel Joints in the Marine Environment. So that's specifically looking at joints for the Type 26 global combat ship. I really liked the idea of working with BAE Systems on an industrially relevant project. So in this case, lightweighting of ships is really important. It allows us to get much sleeker hull forms that allows the ship to go faster, makes it more agile, and increases the payload of the vessel. My project is really focusing on how do we actually connect these lightweight structures to what is traditionally steel. So what we'd like to do is bond these structures to the vessel. Unfortunately, new issues then crop up. So the quality and the strength of these bonds is really important. It's really hard to actually assess that. So I'm using thermal imaging to capture the stress state across the field of view. Now, when a material is pulled, it actually generates a tiny amount of heat, and these cameras are sensitive down to about 20 millikelvin. A tiny, tiny temperature change can be detected. Now we can relate that temperature change to the stress at any given point. So for every pixel on our camera, we're getting a piece of information about the stress state. Now the other thing I want to do is I want to understand how strong these joints are. So the integrated sensor that I'm trying to develop at the moment will be placed within the joint. Eventually the load is going to be too high for the specimen, it's going to fail, and that information is going to let us know basically is our sensor making our joint stronger, weaker, stiffer. We actually believe we might increase the strength of the joint with this material that we have. At the moment, this is one of the issues that's stopping composites being used in marine structures. So if we can really crack this problem now, it opens up a huge world of opportunities in terms of implementing similar structures in all sorts of different naval ships, but also for other commercial vessels. So that's the brilliant thing about working with BAE Systems. You actually get to go on site. So I got to actually do some really cool things. I got to go and look at the Hunt class minesweepers, and they're really interesting from my point of view because they're made completely out of glass fiber. So that was the highlight of my secondment. But even just working within the teams, learning from the other guys, and I also got to manufacture some specimens that I took back here and was able to test. So that was something that I couldn't have gotten anywhere else. The fact that it's an industrially relevant project, I think that's fantastic. It means that what you're working on isn't just going to stay in some dark room somewhere. It's going to go out into the world, and it's going to be applied all over the place. So that's really one of the main reasons I picked it, and one of the reasons I'm really enjoying my PhD so far.